Alright, multiplying matrices. Now, there are formulas, there are tricks for all of these things. I'm going to maybe show you those at the end, but I think the easiest way to think about multiplying matrices is a very visual way. Let's start off with two square matrices. Say 1, 2, 3, 4, -1, 0, 3, 8. And let's call these A and B. And so we're going to make another matrix. Here's how this works. The resulting matrix, this will make sense in a minute, is also going to be 2 by 2. We have 2 by 2, 2 by 2. The answer is going to be 2 by 2. And what we do is to find the 1, 1 position, the 1, 1 entry of the matrix, you take the first row times the first column. Now, what do I mean by row times a column? What I mean is you imagine taking the first entry of the first row times the first entry of the first column. So 1 times -1. So you'd have 1 times -1. And you add to that the second entry of the row times the second entry of the column. So you'd have 2 times 3. Right? So that's -1 plus 6 is 5. So 5 would be the result here. To get the 1, 2 entry of the resulting matrix, you take the first row times the second column. The second column. First row, second column. First row, second column. So once again, so we would take the first elements in each, the first number in the row, the first number in the column. We'd have 1 times 0, and then we add to that the second element in the row, the second element in the column, 2 times 8. Whoops, getting ahead of myself. Which is 16. So this is going to be 0 plus 16. So 16 would be the result. For the 2, 1 position, the second row, first column, what do you think we're going to need? Second row, first column. All right. So then we multiply the second row by the first column, meaning we would take 3 times -1, the first entries of both, plus 4 times 3, the second entries of both. That's -3 plus 12 is 9. And then, for the last entry, the 2, 2, the second row, second column, what do you think we do? Yeah, we use the second row times the second column. And so that would be 3 times 0 plus 4 times 8. That's 32. And this is the result. So this is AB. Now, matrix multiplication is not commutative. Let me show you what I mean. So let's do this in the opposite order. If you think about it, it's not going to be too surprising given how I've defined matrix multiplication. All right. So I'm going to compute B times A. For the 1, 1 spot, it's first row times first column, so it's -1 plus 0, so it's -1. It's already different. For the 1, 2 spot, it's first row, second column, -2 plus 0. Okay. Now going down here, this is the 2, 1 spot. 2, 1 meaning we're going to use the second row, first column. That's 3 plus 24 is 25. And then for the 2, 2 spot, we use the second row, second column. This is 6 plus 32 is 38. So the punchline here is that AB is not equal to BA. Matrix multiplication is not commutative. That is, i.e., order matters. All right, let's do one more example with 2 by 2 matrices, or maybe something else. It doesn't have to be a square matrix. In fact, let's think about this. Let's take 1, 0, 3, 2, 1, 1. So this is a 2 by 3 matrix. Now think about how we're doing this. We're taking rows from the first matrix times columns in the second. If I take a row that's 3 entries long times a column, my columns have to be exactly 3 high. So I have to have columns that have 3 numbers here, which means 3 rows. So I have to have a matrix that's 3 by something. Now, it doesn't actually matter what the second number is. Let's pick another number, say 4, right? And show you how that works, and show you what the resulting matrix looks like. So let's do 1, 2, 0, 0, 1, 1, negative 1, 0, 1, and 2, 3, 2. This is a 3 by 4 matrix. You can multiply these. What are we going to get? Let's see what happens. For the first row of our result, if we call this A and B, then AB above here. For the first row, I'm going to take the first row times each column. So for the 1, 1 spot, it's first row, first column. That's going to be 1 plus 0 plus 0 is 1. For the 1, 2 spot, it's first row, second column, 0, 0, 3. For the 1, 3 spot, I just keep on going. Take the first row, third column, that's a minus 1, 0, and 3, so that's a 2. And then there's also a 1, 4, because there's a fourth column, first row, fourth column, that's a 2 plus 6 is 8. Now I've used my first row up. Now I'll go to my second row. Second row times first column, which will give me the 2, 1. That was a 2 right here. So that's 2 plus 2 is 4. Then I go here to 2, 2. Second row, second column, 0, 1 plus 1 is 2. Then I go to 2, 3. Second row, third column, I get a minus 2, a 0, and a 1. So minus 1. Then I go to 2, 4. Second row, fourth column, it's a 4 plus 3 is 7 plus 2 is 9. Now there's nothing left to do. I don't have any more rows, I don't have any more columns. The resulting matrix is 2 rows by 4 columns. This is not a coincidence. If you look at these numbers, if you take an A by, I shouldn't use A, let's do a W by V, let's not do that. Let's do an N by M matrix, then we know that the number of columns has to equal the number of rows on the second one. So it would be an M by R. If you multiply these two matrices, what do you get? You get a 2 by 4, you get an N by R. So if this were A, and if this were B, this would be AB. You don't have to memorize this. It almost never comes up. You can just figure it out. Now notice that not only is matrix multiplication not commutative, it's not always possible to do the reverse. You can't do BA this time. It's undefined. If you had B, you'd have a row 4 elements long, but you can't multiply that by a column too high. So in this case, we can multiply A times B, but we can't reverse it. So if you have square matrices, you can multiply all 2 by 2 matrices with all other 2 by 2 matrices. You can multiply it both ways, even though the results are different. For rectangular matrices, for non-square matrices, the product is only defined one way, if it's defined at all. For example, suppose we have a 1, 0, 1, 2, negative 1, 0, 3, 1, 1 matrix times a 2, 1, 3, 2, 1, 5. You can't do this one. This isn't even defined, right? This is a 3 by 3. This is a 2 by 3. These don't match. But again, you don't have to remember that. If you try to multiply this row by this column, how would you do that? There are only 2 numbers here. You can't. It just doesn't make any sense. So matrix multiplication is not always defined. And when it is, you can't always do the reverse. And when you can, it's not the same. So there's an introduction to matrix multiplication.